Going to see about let a of n greater than or equal to 1 be a bounded sequence in R. Which of the following statement is false? Here the given options. So if it is a bounded sequence means what are the options or the false in the given option. So if it is a bounded sequence means definitely both infimum and supremum are equal. So if it is equal means it is a convergent. So this option is correct. Before that we need to know about some form. So infimum of an is less than or equal to in limit n tends to infinity infimum of an less than or equal to limit n tends to infinity supremum of an less than or equal to supremum of an. So what is limit n tends to infinity supremum of an? It means if we has an means up to a1 to an, so we have to take the supremum of a1 to an means we obtain some value that is b1. We obtain in this which one is supremum, we obtain some value that is denoted as b1, and later neglecting the a1 first term and taking rest of the term as supremum means we get b2, which means in this terms the which has the supremum value is written as b2 for our notation, and later neglecting 2 means a3 we get some other value that is b3. So for all the supremum then we have to take a infimum of this answer means that is called limit n tends to infinity supremum of an. So for example here the infimum of an is greater than or equal to 1 and limit supremum n tends to infinity equal to an is an convergent. So an and supremum of n tends to infinity, so this one and this one, so both are equal means definitely it is also equal, so it is a so it is convergent. Then if both supremum and infimum of equal and is greater than or equal to 1 means both this one and this one is equal means definitely it should employ a constant value. So for a bounded sequence we take that for minus 1 whole power n is a bounded sequence. If an is for n equal to 1 it is minus 1, for under other terms n equal to 2 or some other terms it is 0. So if we want to take a supremum for an means definitely it will be 0, and limit infimum of this value means infimum of this value is nothing but according to this is infimum is 0 for minus n equal to 1. So if we take that for 1 the value is 0 and 2 3 4 means if we take the infimum values definitely it will be 0, so both the terms are constant. So this also true and this also true. Here the supremum of an limit infimum n tends to infinity are equal, which means this and this are equal means definitely it should be a convergent sequence, but the option given here is constant, so this one is the false option for our question. This one is the answer. Okay. Next, what is the cardinality of the set of real solution of e power x plus x equal to 1? So, cardinality for the set is definitely e power z equal to means 1 for z is a countable and it must be 0 for 0 for 1. It should satisfy both the countable and 0 conditions. So, for our convenient, we have to draw a graph and simplify the equation. So, e power x plus x equal to 1 means e power x equal to 1 minus x, and we have to say the solution. What are the solution of the x should satisfy that e power x plus x equal to 1 means so how many set of answers, how many set of values we obtain through this form, we have to find that. So for simplification or otherwise we have to find this, or otherwise both are same condition for all x, it should satisfy the condition e power x equal to 1 minus x. So we know that the form of e power x is gradually decreases and it decreases from it decreases from starting and gradually increases to the peak. Then for y equal to x minus 1, this value means for x equal to 0 and y equal to 0 means definitely it should occur in this point. It should intersect. If we draw the line means it should definitely intersect the e power x at only one point. So the solution is 1. The cardinality of the this one is 1. Hope you all understand, and thank you.